We need to consider the concentration of each of the ions in a solution once an ionic compound dissolves or dissociates. The easiest way to do this is to look at the balanced dissociation reaction of a compound when it dissolves. So barium hydroxide, which you see here, we're going to fill in coefficients to look at the amount of each of the ions we have on the product side. So for every one barium hydroxide compound that dissolves, we end up with one barium ion and two hydroxide ions. That 2 comes from the 2 subscript that we had back in the formula for barium hydroxide. The coefficients of the balanced chemical equation indicate the relative ratio of the ions that are present in the solution. These coefficients provide values that can be used to calculate the concentration of each of the species. So if I tell you that you have a concentration of the compound, barium hydroxide, of 0.21 moles per liter, we're going to use that and those coefficients to calculate the concentration of the barium and the hydroxide in the solution. So for barium, we want to start with the concentration of the original compound, so that's 0.21 moles per liter, and then we want to multiply by the ratio of the barium ion and the original compound. So multiply by 1 barium ion, what we're trying to calculate, over top of every 1 barium hydroxide that we started with. That gives us the same answer numerically, 0.21 moles per liter, but now this moles is referring to the barium ion and not the barium hydroxide compound. Same setup for the hydroxide ions in the last part, 0.21 moles per liter, and that's our solution of barium hydroxide. So again, we're going to multiply by a ratio, and this time we want 2 hydroxide ions for every 1 barium hydroxide that we started with. So what we want, the hydroxide will always be on top. So 0.21 times 2 over 1 gives 0.42 moles per liter. So the concentration of the hydroxide ions is not the same as the barium ions in this solution. And that's because of the ratio of the ions from that original formula unit. Let's do a couple more examples of calculations for the ions. For the first one, we want to calculate the concentration of each species, the compound and all the ions in a solution made from dissolving 3.82 grams of magnesium nitrate in 4.73 liters of water. Again, we should start with our dissociation reaction. So magnesium nitrate, which has 1 magnesium and 2 nitrates, when it dissolves, will dissociate into magnesium ions with a charge of 2+, and nitrate ions with a charge of 1-. And again, we want to balance this so that we have the same number of each of those ions on both sides. So for each 1 magnesium nitrate, we will have 1 magnesium ion and 2 nitrate ions. When you have the mass of magnesium nitrate, that can be used to calculate the concentration of the original compound. So for the magnesium nitrate, our concentration will come from the 3.82 grams, which we are going to change into moles using molar mass, and that is 100.33. And we're also going to divide by the volume of 4.73 liters. So the concentration in moles per liter comes out to 8.05 times 10 to the minus 3 moles per liter. From that concentration, now we can figure out the concentration of the magnesium and the nitrate. So for the magnesium concentration, we want to start with the original compound, so 8.05 times 10 to the minus 3. and multiply by our ratio where what we want, which is the magnesium ions, goes on top, and what we're canceling, the original compound, the magnesium nitrate, goes on the bottom. So again, this one comes out to be exactly the same number numerically, but now we're looking at moles per liter of magnesium ions. For the nitrate, same setup. Start with the original concentration, and again, multiply by the ratio where what we want is on the top. So 2 nitrate for every 1 magnesium nitrate that we started with. So now we have 1.61 times 10 to the minus 2 moles per liter. So a different concentration than the magnesium ions. The last one we're going to look at reverses this process. In this one, we have the concentration of ammonium ions, and we want to find the concentration of the original solution. So again, dissociation. So ammonium phosphate. So we will have NH4 in brackets 3PO4. That is going to dissociate or dissolve into ammonium ions with a charge of 1 plus, and phosphate ions with a charge of 3 minus. Balancing this with coefficients, 1 of our original compound will provide 3 ammonium ions and 1 phosphate. So for this one, now we have a concentration of the ammonium ions equal to 1.04 moles per liter. We want to do sort of a back calculation to get the concentration of the original compound in solution. So starting with the number we know, 1.04 moles per liter, we want to multiply by the ratio where what we want is going to be on the top. So 1 of our original compound, so that's the ammonium phosphate, for every 3 of the ammonium ions that gave us the 1.04. So this time we're multiplying by 1 over 3. And the answer comes out to 0.347 moles per liter.